Okay, question 7. You might have, well, you should have learned about concave and convex curves in independent week, I think. So if you haven't learned about the difference between concave and convex curves, I think it's exercise 9I. You need to go back and check over. Essentially, if a curve is concave, then that means that the second derivative will be less than or equal to 0. So it's fair, if you know that, the question is fairly straightforward, because this is easy to differentiate. If y equals x cubed plus 6x squared minus 12x plus 6, dy by dx will be 3x squared plus 12, oh dear me, plus 12x minus 12. Differentiate that again. I'm having a nightmare in this question. Differentiate that again, and that will give you this. So in order for this to be concave, this will only be concave if the second derivative is less than or equal to 0. In other words, this will be concave when 6x plus 12 is less than or equal to 0, which is when x will be less than or equal to minus 2. So the question is the interval minus 5 to minus 3. So this inequality, this will be true. This will hold this inequality. This will hold for any value of x between minus 5. Any value of x between minus 5 and minus 3. This will obviously be true for. So therefore you can say that the curve C is concave over the interval minus 5 minus 3. Just a quick point there. A lot of students, when I mark this question, a lot of students just work out, they find this fine, and that's probably 2 marks. But to get the 3rd mark, it's not sufficient to just work out what it's not sufficient to just put in minus 5 into here and get, what's that going to give you, minus 18, and then put in minus 3 and get, what would that give you, minus 6. That's not enough. I mean, you obviously these are negatives, so the second derivative is negative at this point and at that point, but you're not proving, this does not prove that the second derivative, let me just write that down, does not prove that the second derivative is negative between these values, between minus 5 and minus 3. So if you did this method, which a lot of students have done in the past, then don't do that. To make sure you get the 3rd mark, you need to do it this way. Okay, so solve the second derivative less than or equal to 0, solve that inequality, and then write down this final statement for when the inequality holds. Question 8 looks like a rates of change question. with these, I think it's always a good idea just to write down what you're given in the question and write down what you're trying to find first of all. So the radius of a sphere is increasing at a constant rate of 2 centimeters per second. Wherever you see the word rate, you know you're going to have a dt on the bottom. Now the units are centimeters per second, and it's going to be radius, so it's dr by dt because it's the radius. But if you weren't sure about that, just check the units. The units are centimeters, so it's not going to be volume. It's got to be a unit of distance. Okay, so it's always check the units if you're not sure what to write here. It's centimeters divided by seconds, so it's dr by dt. Anyway, we could just leave that as it is, and now see what else we're told in this question. We've got to find the rate of increase of volume. Okay, so we want to find dV by dt. So again, whenever you see the word rate, you're going to put a dt on the bottom. Okay, so what we're trying to find, let me just write down, we're trying to find that when r equals 2. So what we're trying to find is dV by dt. Now, as a general rule, you can just write this, whatever's here, you can just write here, and then whatever's here, you can just write here, because we're going to need to use the chain rule. You know, usually with these rates of change questions, you need to use the chain rule to solve them. And then you need to work out, well, what's going to go here and here. What is the other variable that isn't mentioned in here yet? Well, the other thing that's not mentioned is r. Okay, we've already come across r up here. It's mentioned the radius. Whoops. So what's going to go here is dr, and this is going to be dr as well. So we're going to need to find, well, we already know what this is, so we already know that dr by dt is 2, so we can already substitute a 2 into there. But we've got to work out what dV by dr is. And now in order to do that, we need a formula connecting V and R. Fortunately, it helps us out in the question. It tells us, just in case you weren't sure, but the volume of a sphere, you probably came across at GCSE, is 4/3 pi r cubed. So in order to find dV by dr, we're going to need to differentiate this, which will give us 4 pi r squared. So then we can put this into here, and we're going to put our 2, so let's stick 2 into there, and that's going to give us dV. I should just make that a bit bigger because it's volume. dV over dt equals 4 pi r squared, so 4 pi r squared times by 2, which is 8 pi r squared. And the question says we need to work out what dV by dt is when r equals 2. So we can say that, we can say that when r equals 2, dV by dt equals 8 pi times by 2 squared, which is just going to give us it's going to give us 32 pi, and you should probably put the units down. Leave this exact unless it says otherwise. So 32 pi it's volume divided by time, so it's centimeters cubed per second.